Hello, and welcome to
Hi.
today's webcast, Database Strategies for Mobile and IoT Apps, Why REST Won't Cut It Anymore. A few reminders about the panel on the right of your screen. Please feel free to chat with your fellow attendees in the chat section. We also have a Q&A section in that panel. Don't wait until the end of the discussion. Keep the questions coming in as you have them, and our speakers will address them, as many of them as possible. So do take a look too in our doc section. That's going to give you some helpful links and resources. And as a surprise, we have some bonus features available in track 2 of this webcast that Mark is going to preview a little bit later. But we hope you'll check that out after the event today. So today we have an all-star cast. Mark Gamble, Product and Solutions Marketing Director. And he's joined in a discussion today with Aaron LeBeau, Senior Developer at Couchbase with over 27 years of experience. And he is here to lend his expertise in building mobile and IoT apps. And with that, I turn it over to Mark Gamble.
Awesome. Thank you so much, Suzanne. Hi, everybody. Welcome to the program. And as Suzanne said, today we're going to be discussing mobile app development and specifically dive into some of the challenges and roadblocks that many of you have likely faced while building your own mobile apps. And we'll talk about ways to overcome them. And of course, because we're a database company, our lens is going to really focus on data processing, because how you handle data for your applications has huge implications on user experience, right? So getting it right is really key to adoption. And I'm super, super excited, really jazzed to be joined today by Aaron LeBeau. Suzanne said, Senior Developer Advocate at Couchbase, good friend, and a genius, I think. I really appreciate you being on today, Aaron. Thank you so much for joining us today.
Oh, no, absolutely, Mark. I'm excited to be here. And as you know, I love talking about mobile a lot. Been doing mobile development for probably about the last 12 years of my career. So it's something that hits home often. And really, what's a mobile app without data, right? I mean, it's just a blank screen. So data is so important to everything we build.
Totally. So let's go ahead and get started with some basics about the current state of mobile app development to kind of set the stage. Why are we here? And jump right into it. So I'll start off. Mobile app usage is really increasing worldwide, not only in user volume, but in daily time spent on apps. I read an article not too long ago on TechCrunch, who reported that mobile users now spend between 4 and 5 hours, roughly a third of waking hours on smartphone apps daily. So it just boggles the mind. And actually, it's not too much of a stretch of the imagination when I start taking a look at my own habits on my mobile device. And when it comes to which apps users can choose from, there's no shortage of choices. Google Play currently offers around 2.8 million apps and games, and the Apple App Store offers around 4.5 million. Just tons of stuff out there. But the huge volume of apps and increasing length of time that users are spending on them doesn't mean that any given app will be successful. In fact, it's quite the opposite. Nearly 1 in every 2 apps are uninstalled within 30 days, and losing 80% of mobile users is considered actually normal for all but the most popular of applications. And a big reason for the high rate of app abandonment is bad experience, particularly slowness and unreliability, lack of reliable applications. 70% of mobile app users will abandon an app if it takes too long to load. And 84% of app users will abandon an app if it fails just 2 times. So a big reason for the high rate of app abandonment, is really emphasized. This emphasizes that margin of error is really small when it comes to keeping users happy and engaged. Providing a fast and reliable experience is really key to the success of your applications. And using the right database, one that's built for mobile apps, is really kind of the key to achieving it. So it's no surprise to probably any of us here today that users don't just expect apps to be innovative and personalized and responsive and all of these things. They actually expect magic. We're all users. We expect magic. We want apps to defy physics and work at lightning speed all the time, no matter where we go. We expect an always fast, always on experience, or we just abandon without hesitation. give it 1 star and off we go. And to make matters worse, we're constantly moving around in and out of network coverage. And that makes meeting these expectations even more difficult. So how can an app deliver always fast, always on experience under these kinds of conditions? So current approaches to developing mobile apps probably aren't helping, right? Building apps that are based on calling REST endpoint APIs can start out seeming easy until you begin to hit some of the pain points. Using REST can require developing complex code to do things like detect when the network is available and when it isn't, and retry requests until it's restored. And when you use and reuse REST APIs across applications, it can make apps inefficient, not only to run, but to build, right? Especially complex apps that modify or edit data a lot. You end up doing things like over and under fetching, which you then have to merge and filter with code on the device. And this adds to development time, introduces processing tasks to your app that waste bandwidth and makes things slow, saps battery life. Not going to meet expectations with that recipe.
Yeah,
and this internet, yeah.
Oh no, I was just gonna say, the other thing that adds is regression, right? You have the chance of bugs. The more things you're touching and doing, the more chance you have of making a mistake, right? And now you have regression bugs that possibly can pop out, and now you're trying to fix defects. And it's just, as a developer, it's always painful, always painful.
I feel the pain, exactly. And, the users don't know this, of course, and probably don't care. That's the other irony here and drawback of this approach. This internet availability thing can become a real hassle, right? The cost of determining network availability, doing retries, incurring defects introduced by unstable network connections can be huge, and it impacts performance and user experience. So, to meet the expectations of those fickle users, you have to change how you handle data for your applications. So as we dive in, before I turn it over to our subject matter expert, a little bit about Couchbase, just to set context and a frame of reference. Couchbase is a cloud-native NoSQL database that's used to power gigantic applications. If you're a LinkedIn user, you're a Couchbase user. Tesco, Comcast, Amadeus, household names, big enterprise customers that use us to power their critical applications. And Couchbase is multi-model, and this means that it's a combination of NoSQL concepts that we merge together into a single technology. First, it's the key processing of key value information in memory for hyper-fast responsiveness. And add to that distributed storage of JSON document-based data for flexibility and resilience. And then to this already powerful recipe, we add full support for containerization, mobile and edge capabilities, which we'll be talking through today, and a full set of built-in features like SQL query support. You don't usually find that within a document database.
No, you don't.
Search built in, eventing built in, analytics built in. These are things our customers don't have to bolt on from a bunch of disparate technologies and complicate their stack. So, of course, I'm just trying to go briefly. This is not a pitch for Couchbase per se, until the end, of course. But we did want to make sure that you understand we're coming from a place of tremendous credibility in database and data processing. So Couchbase Mobile is our mobile database platform. That's our support, represents our support. It's a product stack made up of 3 components. Couchbase Capella. This is a fully managed cloud NoSQL database as a service. It's Couchbase in the cloud. And then Capella App Services. This is fully managed backend services for sync, authentication, and access control for mobile and IoT apps. And then we have Couchbase Lite. And this is the embedded NoSQL database for mobile, IoT, and custom embedded devices and applications. So the Couchbase mobile platform is mature, right? Launched in 2014.
Yep.
It's used by customers like PepsiCo, Emirates, Louis Vuitton, Lodem Games, PG&E, and more. The list goes on, as they say.
A bunch of cruise lines.
They all use it,
right? A bunch of cruise lines.
A bunch of cruise lines. Yeah. If you're ever sail on Carnival, you use their apps and their Ocean Medallion that's powered by Couchbase.
Yep.
So, and they all rely on Couchbase Mobile to power their apps, to keep them always fast and always available. All right. So now, as we transition, we all out there are trying to make sure that our own mobile apps are always fast and available, right? Just like Couchbase customers. And if you're doing this, you may face some of the challenges, especially if you're using REST APIs for data. And Aaron, I know in your years of development, you've run up against a lot of these challenges. So what are some of the bigger ones that you've faced using REST? And let's go ahead and dive into Aaron's perspective.
Absolutely. Let's go to the next slide. So here's what, I'm going to go through my top 5 that I think are just total pain points that every developer eventually is going to run through their career. That you've probably already seen it before, and you try to bolt some kind of solution on it. And to remind yourselves that anytime you're bolting on tech that you have to build, that's adding on to your tech stack that you have to maintenance, right? So that's not about writing it once. That's about not only writing it, but also maintaining it. So let's talk about the most common thing is, well, we're just going to reuse the REST API from our web app. And so I always find this kind of laughable, because if you're building a mobile native experience, you went to mobile native because the web app doesn't work. Well, if you're saying the web app doesn't work, then the APIs are written for these big web apps that have really complicated data that pull down megabytes of data sometimes. Probably ain't going to work for your mobile app. It's probably not, right? It's just going to be too fat. We call that fat REST APIs, where the API just comes back too much information. The end user doesn't need all the information. The mobile app's a more specific use case for doing things on the fly on their mobile device, right? So then we go as technologists and we say, well, okay, we've got a couple different ways we can solve this. We'll just put a facade in front of it. And so a facade is like an API that sits in front of the big fat API and tries to thin it down. It tries to go through and say, we'll build a API that answers that REST API. We're putting a mat in the middle. So now you're adding latency. You're adding code that you have to go through and maintenance, right? And you're adding a whole nother layer onto your application. And we'll get into a little bit later on why that is just a terrible idea. But when it comes down to it, reusing your REST APIs, if they're developed for a web app or something else, almost never works in mobile. You almost always end up having some kind of hack of like a web facade or other. You try to bolt on other kind of technology to try to solve this problem, saying, how do I get the data that I only need for that screen on my mobile app? And that's a challenge, right? And then that also goes on how mobile apps are built. And I'll give you an example. One of the things that drives me crazy is how we filter data, right? If you even think about it, most web apps have like this big table of data, right? Say for example, it's an expense report. You got a bunch of expense reports due and stuff. So it's in a table. Well, mobile, we don't have tables. We don't have pagination, right? Think about the last mobile app you've installed in your Android for the iPhone that has a page number at the bottom. You're selecting page 4 or 5. It doesn't happen. We have infinite scroll, which is a different piece of technology. So now we're trying to figure out how do we take this mobile way of thinking about presenting data to people and try to bend it around these APIs? And then the terrible part about this is that halfway through scrolling, you have to start making a decision of, hey, I have to call that REST API and have it back, all the data back in time, so that when they get to the bottom of the list, the next piece of data is there, so the data looks like it's fluent, looks like it's constantly flowing, and and that's what infinite scroll is, right? Infinite scroll isn't, I get to the bottom of the list and I have to wait for 5 seconds for this REST API to give me some data so I can start scrolling again. That's a bad experience. That's what you're talking about earlier, right? It's a terrible experience when these things happen. This is kind of some of the stuff that you're signing up for when you're reusing a REST API that wasn't designed for mobile. Let's go on to the next slide.
Sure. And as we do, I mean, it's probably approached innocently enough, right? Oh, that API will return exactly quote unquote what we need. And approached innocently enough until you go, oh, there is no multi-purpose. Serve everything from a single endpoint, right? Yeah,
and a lot of times, I'm not trying to pick on people or different roles and stuff, right? But a lot of times a product owner or the business will come back and say, well, you could just reuse the API. And it's not until it gets to a technical person on the team, they go, hey, we can't do this. We've looked at this. This API just doesn't work. And then the product owners go, well, wait, why doesn't it work? And then you're trying to explain, you're trying to do all this stuff. All that stuff, it just adds to delays, all kinds of other things just going to happen that are bad. But if we look at it, here's my second thing I just absolutely aggravates me me inside of REST APIs. And this happens more often than it should. See, JavaScript is a kind of, in most web apps, with just Minute, are built in JavaScript. It's the most popular language on the planet. If you look at Stack Overflow, 66% of code written out there today for web apps is written in JavaScript, right? Well, the problem is, right, JavaScript isn't type safe. So now you have this problem where you have these APIs where, hey, we have the currency, but we're storing it as a string sometimes and as a number other times. Right. And so now the problem is we have a bug. Well, the JavaScript team's just going to fix that in the web app, right? They're going to say, hey, if we get the data back as a string, we'll just take it out. This is really easy to do in JavaScript, right? But the mobile team doesn't know about that. So now the mobile team gets the bug in, and now they're trying to fix it. They're going, well, wait, we don't do that because most mobile languages are not typed. They're type safe, which means, hey, you have to give me a number if I ask for a number. And during the serialization process where we take that JSON data and we turn it into native objects that we can use in memory, like in Swift or Kotlin or Java, Object-C, or even C# on .NET, this turns into a problem that we have to deal with now, right? So now we go to the API team and say, hey, look, there's a bug, right? We have a bug to fix. And then the API team says, great, we're going to fix it. Now we have to wait for a release. And then the mobile team goes, whoa, 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 whoa. Okay, do you know how hard it is to release a mobile app? We had to go to Apple to get approval for doing all this. So now we have two versions of the API. We have to go through to try to schedule all this stuff. Usually you're trying to coordinate with everybody, try to get a release out to get this fixed. And then the web team may not know about it. Now the web team is going to be broken because they're going to fix that API that the web team has a patch in for. And so now you have all this craziness going on between your development team of like this one little tiny bug that happened because of the fact that the API is designed for JavaScript, and the JavaScript team, they're just used to fixing these kind of things in the web, in the front end, versus telling the API team to fix it in the back end because of an API change is more expensive than a front end change. And so this is why reusing REST APIs designed for web apps, it's another reason that there's just no lack of schema and validation, this data validation that's really kind of required when you want to take that API and use it in multiple spots outside of just a web app. Mark, let's go to the next slide because there's so much more I want to talk about. So here's the next thing, right? This is this gets talked about a lot on Twitter. Let's just be honest, right? Clean architecture. Every dev that has done this has seen it on LinkedIn or Twitter. All these debates about like how do we even handle this kind of things, right? So we say, well, okay, we're getting data from something. We don't know what, right? But now it's not in the shape we want it to be, right? Let me give you an example where like, hey, I have an expense report app, right? And the expense report app, I only have 4 fields on the screen I actually care about. Okay, I care about the name of the expense, the month it was due, who it's assigned to, and like, how many dollars that expense report's worth, right? But this object comes back with like 30 fields. You're like, what? I don't need those in memory. And in fact, if I have a long list of those, that's going to chew up memory that I don't want to be using battery for, right? So I need to thin that thing down. So now we have patterns called data access objects. There's also things like DTO objects. A data access object, that's really pop for just like, hey, during my serialization process, just ignore these fields that I don't use in mobile. They're used in the web app, but I don't need them. So you just try to kind of take them out of not being there. But this costs you code. You're going to have to write all these codes for all these different things. You have to manage it, right? And now you're adding more patterns to try to solve this problem because the API wasn't designed in the way. So you're trying to add all this complexity into this where mobile apps are supposed to be small and simple. Most teams are like less than 5 people that work on a mobile app. Let's just be honest, because they are designed to be efficient, small, and great. You start adding all this extra code to try to figure out another way to get rid of all this data you don't need, or try to transform the data in a way that shows up in the mobile screen, which is another example, right? Where we have to call 3 different REST APIs just to get the data that you're looking for on the mobile screen in a way that the user needs to see it. And I always say this is MC squared. And people say, what? And it's my favorite joke is errors equal more code squared, and that equals EMC squared. Now, EMC squared in the physics world is awesome. It's one of the greatest formulas in the world. But anytime we add more code, we have more chances of regression, bugs, and et cetera, et cetera. It's just never great to do. And so this back and forth of transformation of data in order to serialize it, deserialize it, put it in the shape we need for our mobile app, it's not buying you anything. The end user doesn't care. It doesn't even know about all this. All it wants to do is see its data. And now you have to put all this extra process just to make it work in your mobile app. It's just not great. I'll just be honest with you. It's not a great experience, right? For the mobile developer to keep track of all this extra code that you have to put in. So let's go on to the next slide.
so many headaches, it seems, for the
It
developer, and
really
you're
is,
still
right?
not getting ahead on the user experience.
Yeah,
It's
right. And so,
that, yeah.
and this is what the next thing ends up happening, right? So now we're trying to take this modern world we live in, where we have data that we care about. Let's go back to that expense report example. I have an expense report and I have a bunch of expenses in it. Well, normally in this world, you'd have like some kind of REST API that manages and looks like a CRUD operation. And this is very similar to like relationship databases, where we say we have a table that stores an expense report, but all these expenses are in a separate table you have to join to. And so the REST API is written in that way also. But the end user doesn't care. They want to click on their expense report and see all their expenses they have to see whether or not they got that receipt that they did for the coffee shop yesterday. They want their money for that, right? Well, now you have to wait for that API call because the API wasn't designed in a way to bring both those pieces of information back. So now you have another delay, not because the API was designed, but because the way that the API is structured is a way to try to match some kind of database that's archaic and old. And when the modern applications don't even want the data that way, it just doesn't make any sense. In JSON, we could just embed that. And in JavaScript and in the web page, we want that. That's just a embedded object. Here's my expense report. Here's all the expenses. It's just embedded inside of it. Why do we need all this extra complicity and CRUD and all these other things that really the end user doesn't need? And you're just adding on because you have legacy. And that just always is terrible anytime you start thinking about that. And sometimes you have to go through and think about this and go, okay, what happens if we add something to this, right? What happens when we add like an approval workflow? Now we have to change all these APIs we're trying to match it, and we have to try to map all this data to CRUD, and try to figure out like, how do we get this? And we may look at the data a different way, so then the API has to make sure it shows it the same way. And this is where all other defects happen. The example usually is given like books. If you look at books via just the title versus author, you may have totally different queries that bring that data back, and there could be defects in it. So now you're using the API one way and it works. Same data, use a different API, doesn't work anymore. You're like, well, geez, all I did was filter the data in my mobile app. Now it doesn't work anymore. That's not great, right? So it's translating the business model to like, the business domain and all of our business rules around this transport model of like trying to do CRUD and try to have multiple ways to get the same data. It just doesn't make sense. It always feels ugly in mobile, to tell you the truth. It just feels like weird when you're like, hey, I need to filter this data. Oh, you have to call this other API, and then it returns the data differently. You're like, well, wait, what? I just want to filter this. Why am I doing all this, right? Let's go to the next
slide. This constant bending, trying to reshape between
really
these two. Yeah, wow.
Yeah.
Let's talk a little bit about the fifth pain point here.
Yeah, right.
And like you said, this is almost like, almost too easy.
Yeah, right. So the final thing that ends up happening, the most biggest annoying thing in mobile, right, is when we have loss of internet connection, right? And we have several different things that could happen. One, we just lose the internet connection altogether. That means we have to try to validate, is the API down? Is it broken? Is it because the person went on airplane mode because they just jumped on a plane? We don't know why, right? And we have to write code to try to detect that. And then now we have to also worry about, okay, are we going to allow some kind of offline mode? Okay, what happens when that happens? How are we going to sync that information back up? We have to write something ourselves usually, right? And this kind of is not great. You're caching data locally on a device, and now you have security possibilities. If it's not encrypted, you have to start thinking about all that kind of stuff. If you're building like healthcare applications and stuff. And now you also have to deal with the updates of like, what happens when I pull the refresh, and that's not available? How do I help it, and how do I calculate all this kind of stuff? Now, most mobile developers tell you, well, if the API is slow, we're just going to cache the data in memory. That's one of the solutions to the problem. So now you're building this entire cache engine. We are trying to bring the data down, cache it in memory for a certain period of time. Then maybe you're using something like polling or long polling, which is these really old archaic ways of trying to go ask the API if there's new data. And then you're trying to merge that into your cache data. You're building super complicated engines now to try to handle all this stuff. And the end day, the end user is missing the three features that they asked for because you're spending way too much time building back-end technology to solve all these problems instead of building the features that the user's asking for. The user's asking, where's my expense report ability to take a picture of the receipt and attach it so I can just send it up and get approval for my coffee that I just did? And instead, you're spending all your time building all this back-end and mobile technology trying to get this data in a way that they could use it, regardless if they're on a plane or not, right? Because let's be honest, I like to do my expense report on the plane trip back a lot of times. And I don't have internet, and the internet's not reliable, and I'm taking pictures of all the receipts and stuff. stuff and no internet connection. How am I doing on my expense report now, right? This is a very common scenario for me. And so this is like, the theory of like dealing with unreliable connections. Also in the US, here's a favorite statistic I have. Just so you know, if you're driving down the highway, that's where all the cell phone towers are. Because in rural America, that's where most people are driving. The second you get off the highway, your internet, if you're in rural America, you have no idea what that cell phone service could be. It could be 1, 2 bars, maybe 3 bars. And there's still part of the US that there's no cell coverage or very little cell coverage. I come from a part of Upper Peninsula of Michigan, where I used to live when I was growing up. There's still like an hour and a half of dead zone there where you have no internet. And that happens all over all the time, right? You just can't guarantee that a cell phone has internet connection no matter what. You could be at a concert and there's 90,000 people at that concert. And it's not that the cell phone's tower is down. It's that it's overloaded because there's 90,000 people at that concert and there's just not enough bandwidth for everybody. So the problem is that people think when they have cell phone signal that they have data. That's not 100% true. You could be in a very crowded area and not have any data whatsoever because of that, because it's a shared resource.
Yeah, it's interesting because I've run into, talking to industry analysts and pundits, and I heard, the globe has almost 100% coverage. You can get anything you want anywhere you go. And I'm thinking coverage doesn't equal a fast, reliable experience. They are two different things.
Absolutely. I totally agree.
You make a great point. Wow. So, really, I think your insights are awesome. And it's really clear that even if you code around, all of these REST hurdles, you still can't guarantee a good user experience. And back to how we started off, that's where if you don't have a good user experience, you've lost them, right? So we see often talented developers can code around anything, but then you have to figure out what cost, right? Is it going to erode performance? Is the app going to make your battery sap faster? And these other things that you don't realize it until users are leaving.
Well, this is the thing. Is your team's job to build the expense report app, or is your team's job to build a bunch of technology to try to solve problems of getting data? Exactly. You want to be in the business of building apps for customers, right? You don't want to be in the business of building technology because it's going to add on technical debt onto your backlog. In the end of the day, the end user doesn't care. They just want to use the app in the way they want it, right? So this is where, investing in finding people that are experts at this is way better than trying to be an expert yourself. Instead, do what you're good at, building mobile apps, building awesome UIs, integrating cameras and Bluetooth, right? Do those cool things. Then find somebody that basically builds good backend for you that makes it so that your app can be seamless and awesome to your end users so you can get features out faster, because that's what ends up winning in mobile apps. When you can get new features, updates out, and things that users want, people will use your mobile app.
So let's get into this. How do you solve these problems? And you can do it by changing how you handle your data. So now let's transition over. I'll take the mic for a little bit, and we'll talk about some mobile database platform concepts. So what mobile database platform, what is it? It's intended to really simplify data handling for applications, as well as work around the inherent unreliability of the internet, which we've just been talking about. So the other point that we like to make is it's not about eliminating the cloud, which is extremely valuable for scale, elasticity, and a standardized environment. It's actually about extending data storage and processing, extend that footprint for apps from the cloud to the edge, including onto the device itself. So, a proper mobile database will eliminate the REST pain points, reduce internet dependencies, and speed up apps with local data processing, all without sacrificing consistency. So with that, we come to the mobile database essentials. So there's really 6. This is actually excerpted from a D-Zone paper that we produced. And it covers these 6 areas: local data storage, flexible data models, data synchronization, security, platform support, and flexible deployment. So for the sake of time, and also because we'd like to address specifically how a mobile database platform addresses those pain points, we'll focus on the top 3 here in today's session: local data storage, flexible data models, and data synchronization. So first, let's get into local data storage. And as we've been saying throughout, right, all mobile apps require data persistence to maintain state, ensure a consistent user experience. But where and how you store the data and where it's accessed has a huge impact on app speed and availability. So if your mobile app's intended for use where network connectivity is fairly reliable, such as within a major city, you may need to account, of course, for users going into tunnels, onto elevators, subways, that kind of thing. And for handling these disruptions, some cloud database folks offer a local caching mechanism to maintain app availability when the network's not available. And the approach might be useful for occasional lapses in connectivity, but introduces inefficiencies that, when the app is offline for too long, because rights are collected and held in queue until they can be committed to the backend cloud database. And as the queue grows, it can begin to impact app performance. And local data caches typically have a limitation on the amount of data allowed to collect. And if that's exceeded, the risk of data loss starts to increase. And local data caching strategies should really only be considered for apps that'll run in areas with a really high degree of reliable network connectivity. But where is that anymore?
Yeah, right. I agree with that. And so the other thing people forget is that local data cache, if you're storing that on memory, for example, you're burning battery, right? And now you have to think about it. You're storing, and a lot of these solutions are the full object, the full data in memory, and they're not going to sync just like a small change. Say, for example, you have that expense report, and all I do is add one little tiny dollar amount to it, right? The rest of the data is exactly the same. Well, they're storing the whole thing in the cache until it comes available online. They're going to blast that whole thing back out, which is not great. To tell you the truth, that's a pretty bad experience, and you're really costing the user battery life and those data limits. In the US, we have what they call unlimited data, but the rest of the world isn't that way. A lot of times people still pay for data. We talked about how sometimes these big REST APIs can be. It's not great when you start blasting out 20 megabytes of data, because that's how your REST API handles getting data.
Inefficiency, just because it's assumed free data plan, is not no excuse for inefficiency.
Absolutely.
Now, it's so true, right? And transitioning to the alternative, unlike a temporary cache, a local embedded database, brings far better resilience. It's a database, right? It's built for this. It has more stringent security, more efficient processing. It's designed for high velocity and long-term secure data storage. And when we talk about embedded databases, these are the features really that you should make sure are in any solution you look at. Query. Learning a new query language or paradigm only slows you down. Look for the ability to use SQL with your embedded database, right? It almost seems like a no-brainer. There's a lot of options out there that don't support SQL.
Yeah, right. But that example, right? Well, think about that example where we have a screen that's totally different than the web app, right? We want just a couple fields in it. With SQL, I can just query that out. I say, here's a SQL query that I only need 4 fields out of all this data. Just give me those 4 fields back from the embedded database. Done. So even if you have that,
under and over fetching, you get rid of all of that nonsense.
Absolutely.
So absolutely. And and what goes with SQL are joins and aggregations and transactions. So make sure that your database not only supports SQL, but all of the attributes, the things that would be expected to go along with the power of SQL. Another thing is search. All applications need it. It's a critical feature. Don't add it as an afterthought. Search requires a database that can index natural language text fields and provide search results based on free-form user input, right? So it's not just a select from where kind of thing. And when evaluating a mobile database, look for built-in full-text search feature, right at the database layer. That's going to reduce complexity of your stack and save you tons of development time. You don't have to add on search capability to your existing stack.
Or even worse, you go to the cloud, right? You go out to the cloud and try to do search. Now, the problem is when the internet's down, once again, your search doesn't work anymore, right? So don't rely on search also to be out there, because you're not guaranteed that's always available.
Great point. So on asynchronous events, if your apps are reactive, you shouldn't have to poll the underlying data layer for changes that affect the app experience. You want the app to be notified of data change events proactively. So look for a database that provides asynchronous event notification at the database as well as individual field or document level, right? So multiple levels of granularity.
Yeah, think about the you use every day, Mark. Think about the apps you use today. How many of those apps you use they have a refresh button? How many of those apps today have some kind of way where you have to tell it to actually go get data? That doesn't exist anymore, right? Mobile users just want, like in Facebook, just to see their new post. They just want to go in there and have it just show up. You need asynchronous events at this point in time. Then you need the ability that if new data gets added to your database, you just fire something and I'll just update my code and I'll update the screen so that you can see those things, right? And there's so many patterns to do this.
Absolutely.
But when your database supports that, now you've write zero code to detect this, zero code to have to do this. It just comes along and you're getting that data almost for free. It's super awesome.
Writing zero code goes pretty fast too, I've heard. So it's all in making that more efficient, right?
Oh, yeah, and when it's in your native platform,
all the way out.
When it's your native platform, it's even better, right? So, it's, for example, in Kotlin, you want coroutines because coroutines in Kotlin is how we handle data streaming, right? And that gives me the ability to be efficient because I'm getting things on the background thread instead of the main thread, so I'm not also slowing down my UI. Over in Swift, we have a totally different way of technology of doing that, right? We also want to embrace those technology stacks at the native way because that's how I'm writing code, right? In C#, I want to be able to use async code to do that so that I can, once again, guarantee I'm not locking up the UI to get these events that's happening. I want those to happen on the background thread. So you want not only these asynchronous events, you want them in your language in the SDK in a way that's supported so you can keep your app looking fluent and awesome.
Exactly. Great points. And in case you haven't guessed, all of these things that we're recommending, Couchbase offers. So we'd also like to implant that as well. Some other considerations to look for: the ability to deploy pre-built databases. For things like faster startup, you can pre-hydrate your app with the data it needs, and it launches faster. Go figure.
Absolutely.
And then things like on-device backups for failover to minimize risk of data loss. Especially important for enterprise apps that handle sensitive data, where you've got millions of users potentially out there. Having failover and on-device backup capability is really important.
Yeah, I've used that whole preload mark. I've used that a lot in my career. That's one of the best ninja tricks that you can come up with. If you think about it, like one time I was building this inventory app. I'm not going to say which company I was working for and stuff, but the theory was warehouses don't change all that often. Let's just be honest. They don't buy a new warehouse every day, right? They buy, maybe we get a new warehouse, even if there's thousands of them, we may only get a new warehouse maybe once a month. Well, then I can just pre-build the database into the app of all the warehouses. When the app launches, I'll just go get the changes and saying, hey, are there any new warehouses? And by doing that, the warehouses are instantly available in that mobile app. There's zero REST calls to it, right? And there's this idea of pre-building where if you're a university, for example, your classes don't change that often. Maybe the teachers do every once in a while, but you could have it preloaded with all that kind of information, and then you just go and say, what's my delta? What's my change since this pre-built database was done? You're only pulling a very small amount of data down. It's one of the greatest ninja. Yeah, absolutely, because you're only asked for delta change. This is one of the greatest ninja things that you could do in a mobile app to make it super awesome. The minute that they just click the button and the data's just there.
We love ninja tricks, 100%. That's awesome. So now let's move into flexible data models. The flexibility of the model can play a huge role in how easy or not it is to adapt as your requirements evolve over time. So, of course, a lot would argue that the debate is over between NoSQL and SQL, but it still kind of rages on when you're trying to choose your database platform. So here's some important points to consider when evaluating a mobile database. The predominant models out there, of course, are relational and NoSQL. We don't spend a ton of time on this because everybody probably knows it, but just to reinforce, relational databases natively support SQL. They excel at storing highly structured data and providing strong consistency. But these characteristics bring rigidity because the data model is fixed and defined by a static schema. So in order to change the data model, developers have to modify the schema. That slows down development. It can also, impact things like app upgrades and the experience for your users. NoSQL databases, on the other hand, are schemaless and document-oriented and storing data as JSON documents instead of tables, rows, and columns. And JSON is also the de facto standard for consuming and producing data for, web and mobile apps. This makes it ideal for development without that rigidity, because JSON defers to the apps and services, and thus, you as developers define how the data should be modeled. If your app development follows the domain model, you want the flexibility to evolve apps without that overhead of the relational rigidity. look for a NoSQL JSON document database. That's a great option for your mobile application. So now we get into arguably one of the most important parts, I think, of the whole equation, and that's synchronization. To build mobile apps, you need a comprehensive data synchronization solution for, data integrity and accuracy, security, a good user experience. Sync means that multiplayer games reflect accurate stats and scores, or retail app catalogs are always up to date, or healthcare apps always show current patient data. Or for IoT, sensor arrays can be monitored and reacted to in real time. So that, this is a critical feature. And a properly applied data sync functionality can also make app updates easier and more foolproof.
Yes.
Right? Even if an update installation goes bad for some reason, the next data sync corrects those inconsistencies.
Absolutely. And one thing that's not applied that I think is really important is also delta changes, right? When we sync, we don't want to sync everything. We just want the changes that were made. If we have this big, large document model, let's say, for example, your user profile, right, Mark? You have your picture on there, your first, your last name, your email address, the department you're in, which office you're located in, and all you do is change your cell phone number. You shouldn't have to send your whole profile up to this REST API to say, here's all the data because I only changed my phone number. You should be able to just send your phone number and say, this is the only thing that's changed. That's called a delta sync. And that's something that in your platform, you absolutely want. It means all the data syncs are super small. The data is ridiculously small, less than 1 kilobyte, because a lot of times people aren't filling out novels on their phone. They're filling out maybe 1 or 2 field changes. So
Delta sync, the price change.
Right, exactly. Right. Delta sync, one of the coolest features. If you have a database mobile platform, you need Delta sync because that is one of the coolest things you can get. It's going to save bandwidth, time, energy. Everything's great then.
Absolutely. I mean, and in fact, we'll cover that in a little bit more. But just to really drive the point home, there's a lot more to sync than, some might say, oh, I'll just build it myself. How hard could it be? But to do it right, you have to contend with conflicts. You have to ensure secure access. You have to make sure sync can go in both directions or either or, the directions. Monitor that network status as we talked about. And then, even be able to handle not being on the internet and take advantage of local networks, for example. So building sync for yourself for mobile apps is inherently complex. Don't do that, right? That takes precious time away. Why don't you use a database platform, mobile database platform with built-in sync? And as you evaluate options, look for these capabilities, right? Under sync management, regardless of how you implement your sync, it's important that you have the ability to control how sync works. So you need to have support for streaming and polling, one-time, continuous, and push synchronization to contend with different use cases. And then, just as you said, Aaron, you want to make sure that you're only syncing the delta. That's important for reducing latency, especially where network bandwidth is limited. And look for the ability to selectively replicate some data, but not other data, using filters.
Yeah.
And for example, if you're have an app that supports a multi-location retail chain, you reduce bandwidth usage by syncing only the data needed for each individual store to that store, rather than everybody gets everybody's data. And on conflict resolution, it's going to happen when you have these huge distributed applications. There will be data conflicts, so you need a system for resolving them. Look for sync resolution that uses revision trees as a default rule. Most active branch wins. This way, conflicts are resolved logically based on activity, not based on a system clock, which, as we know, relying on a system clock can be problematic due to issues of clock differences on devices. And you should be able to create custom conflict resolver policies, and conflict resolution needs to be lightning fast. So you have to resolve conflicts at the device layer versus in aggregate in the cloud. That can bring huge compute costs if you do it all in the cloud, and it increases a risk of data loss and latency due to internet. All right. So now I'd like to jump into, drumroll please, the live demonstration. And let me just get the
This is my favorite part, Mark. This really is. We can see an app,
Mine too.
right? We talked a lot, but it's like, man, the money is where the app is, if you ask me.
Exactly. So first, let's cover what we're going to be talking about. So it's a mobile database platform application, and the app we're showing is on the Apple App Store. It's called Simple Data Sync. So you can use this QR code here, or search for Simple Data Sync on the App Store. It's going to be in our resources as well. And the demo architecture is really straightforward. I have the app running on 2 devices. One is my iPhone, and the other is running on my simulator. I have Xcode up. And the app has Couchbase Lite embedded, and it syncs data between the 2 local devices using peer-to-peer sync. I also have the app on my phone syncing with Couchbase Capella in the cloud using Capella app services. So this means that any other remote user can also sync with my device via app services. So let's transition over to sharing and get to the fun part. All right. So here we are. We're looking at my iPhone mirrored on my screen, and I'm currently, actually, this is my simulator running on Xcode. And I'm currently focused on the color sync feature of the Simple Sync app. And with this feature, I can change the color of the dot by simply tapping it. Okay, simple enough. Moving through a series of colors. Each color is, of course, controlled by a data value, and that data value is stored and managed by Couchbase. So I also have my own phone here, which is running the application. And as I tap this, it can sync directly with the app, running on my simulator. So we built this app for 0 friction. There's no complex configurations, no trying to pair devices manually. You fire it up, put it on 2 devices, and the sync just works with any other devices that are running the application. It's like magic, really amazing. And when we tap either way, I can go over here on my simulator and tap, and it goes to my phone, and I tap on my phone, it goes to my simulator. So peer-to-peer. And this is demonstrating the ability to sync without a central cloud control point. We're not using the internet to sync this color data between these 2 devices. Peer-to-peer sync is used for apps where workers might need to collaborate and sync data in isolation. Like imagine a flight crew in flight, or drilling operators on an oil platform at sea, or a restaurant, where orders are synced from the waitstaff to the kitchen to the servers, all without having to rely on the internet. All the devices are just syncing amongst themselves.
And so, Mark, let me get this straight. So on your simulator, you don't even have any configuration for any cloud servers whatsoever. You're just using the local network on your simulator to say, hey, look, I've got some other client out there on my network that knows about this. Just go ask them for information. That's 100%. Pretty cool. Exactly. Think about that for a second. That is amazing.
Don't buy yet. Wait, there's more. Okay. So what I'm going to do now is go into the application on my phone and go into the settings. And what we have here, notice endpoint. There's a URL, username, password, and it's enabled. So what this is we're utilizing now Capella app services for synchronization. This means anybody that's remote can synchronize with me. And in fact, Aaron, I think you have the app running. You're also connected to my endpoint. So go ahead and start syncing. Yeah, look at that.
I'm changing the color in real time. I logged into my app version. I put my username and password in. I put your server in, right? You gave me a username and password and the URL to your server. Okay. I just put that into my app, and that's pretty much it. Now, here's the other thing that kind of, this is really popular in enterprise businesses. What ends up happening is that a lot of times you have a personal iPad you're running the app on, but you're cheap, so you just get the Wi-Fi version. And then we used to have this really famously. I worked at a company where they do inventory audits, and the problem is their Wi-Fi, the tablet doesn't have any internet whatsoever. It's just got Wi-Fi. The company that they go to for the warehouse doesn't have any Wi-Fi available whatsoever, and all they have their cell phone now. But they want to sync data between the 2. Well, now in that world, you could absolutely do it. Your iPad could be here using peer-to-peer to sync data to your phone, and your phone's taking that same data. So if you change it on the tablet, it goes to your phone. Your phone's what's sending the delta out to the actual server and coming back. And so think about that for a second. That means you're changing data on a device that's not connected to the internet to the other phone. The other phone's even changing making your changes, it's only taking the deltas, if you code it that way, it's sending just that change up to the server. It's pretty awesome.
Mind-blowing. It's mind-blowing, exactly. And it's noteworthy that once this demo became available to our folks, we've been super excited to show it off, and the response has been phenomenal for obvious reasons. And I'd also like to kind of show one other aspect here, and that'll be the Capella equation, right? I've been talking about these app endpoints. So here we're looking at them. There's a color, there's a count, and there's a photo endpoint. I'm not going to go through how to set them up. In fact, Suzanne mentioned our extra special giveaways today are going to be a series of videos that you can look behind the scenes where Wayne Carter, the developer of this application, will show you how he built it and also show you how he set up these app endpoints. But the real key here is that through synchronization, everything is synchronizing through to a document. And what I'm going to do here is go ahead and change it on the server side. And let's go ahead and save that. And you probably saw that both of them, both of my simulator and my device have updated. Probably yours did as well, Aaron. We've just now pushed a synchronization down from the cloud out to all of the devices in this ecosystem.
And that was measured in milliseconds, right? We're not talking seconds here. We're talking milliseconds, and it was ridiculously fast.
Indeed, indeed. So just to kind of round out the different features of the demo application, there's also photo sync. This is similar to the color sync feature, but for photo sync, the data we're syncing is binary. So this is like things like videos and images and PDF attachments and the like. And just like with color sync, photo sync can sync these sample images between devices and the cloud. So applicable app features here are photo or video attachments for insurance claims, or user profile photos, or product catalog images, PDF service manuals, gaming assets, right? We just use emojis just for fun and simplicity, but really all of those things apply.
Yeah, and so those, so from a technical standpoint, just to understand, folks out there, I know there's a lot of developers going, wait, what? Wouldn't that make your JSON document too big? Well, these are blob, binary large data, right? So what ends up happening is that there are attachments, like Mark said. We do a hash on the actual file itself. The hash of what the file is gets attached to the document, and then the actual physical document, the data, that binary data, gets uploaded separately. So it's not in your JSON document. So that's something to remember, is that really, when it comes down to it, that's why this is so efficient.
Absolutely. Thanks. Thanks for that, Aaron. Really important point. So next, I'm going to take a quick look at the count sync feature. And this feature demonstrates syncing of complex data, right? This is data type known as a CRDT, conflict-free replicated data type. It's a distributed data type that allows you to do simultaneous writes without data loss, which is usually a big problem to solve. That Couchbase Mobile makes it really easy. So for example, I'm going to increment the counter up a few on one. On the simulator, I'll increment the counter down. We can see it, of course, synchronizing. But now what I'll do is I'm going to click both the simulator and my local phone at the exact same moment. And what that does is it increments up twice. So instead of registering as a conflict, it actually made sure to count those. And that's important. This functionality would be required, for example, if you're counting people entering an event through multiple doors, where a simultaneous count shouldn't register as a conflict, but rather as two distinct increments. So again, critical functionality for dealing with counters in a distributed environment, typically difficult to achieve, but Couchbase makes it super easy. So lastly, I'll just take a quick look at the search feature. Again, search is an expected feature for nearly any mobile app. And this feature demonstrates all of our capabilities with sophisticated search, including SQL queries and search indexing. So for example, here, I can look for all brown items in our catalog. Or I can search for all brown items that start with S. Or I can look for all brown items that are SO, and now we narrow down to socks. Or I can even do compound queries, brown or pink items. And we see all the brown and pink items. So a lot of sophistication there that again, is expected. Don't bolt on a separate technology for this. You can utilize this right out of the box with Couchbase Mobile. So with that, I'm going to stop sharing, and we've been chewing through the time here. So we need to get back to back on schedule, and
but the mobile app's fun. It was worth it. It was worth it.
The mobile app is fun. That's why we lingered a little bit, if you will. So developers, get the Simple Sync demo app source code. Use this QR code. We're going to put it in the resources also. And for a deep dive code review, we've produced that 4-part video series with the developer of the app, Wayne Carter. He's the Couchbase's VP of engineering. Brilliant guy. And he walks through the code in detail and shows you how he used Couchbase Mobile to build it. So be sure to get that source code. Watch the 4-part series after we wrap up today. It's going to be in track 2 for this webcast, as well as available on demand after this broadcast. So I want to talk just about one customer. I've name dropped a lot, but PepsiCo Frito-Lay just recently has done use case testimonials for us. They use Couchbase Mobile to power their order-to-cash application, and it serves a critical business function for them. Sales reps and delivery staff use it to take and fulfill orders and deliver products and work with their customers in the field. And they came to us with this app that was aging and slow and unable to operate without internet coverage, which happened frequently when in remote parts of the country, right? When out of range sales and delivery staff they had to go back to paper, with all the delays and errors that go with that. And that slowed business and impacted customer relationships. So PepsiCo Frito-Lay turned to Couchbase to modernize that app, remove those internet dependencies, and keep business flowing at top speed. And we delivered, right? Couchbase Mobile embedded data processing with Couchbase Lite that allowed the staff to use the app anywhere without regard for internet. And they conduct business wherever they go. And automated sync takes care of sharing information back to the cloud as connectivity permits. Right? It's all automatic. They were like, we don't want our sales reps to have to rely and hit a sync button. They'll forget every time. Mm-hmm. So automation was another key. And so this is a great illustration of the power of a mobile database platform. So which mobile development platforms and languages does Couchbase Mobile support? Yours.
Yeah.
Our comprehensive language and framework. Yeah. Language and framework support includes native and cross-platform tools. There's community contributed assets out there. And our C API support.
Really, Flutter is relatively new to us, and that's new, and it's all community contributed. I can help with the documentation on that, and I know the developers that work on it pretty well. And it's a great project. There's a lot of people out there using it. Flutter is a really exciting new cross-platform way of building apps from Google. And man, I can tell you that I've built a couple. We actually have some on the developer portal. We have some tutorials on how to use Flutter with it, and it's really a breath of fresh air, to say the least. Obviously, all the normal things are out there too. If you have an older code base, it's we've got Object-C, we've got obviously Swift, your Java and Kotlin, all the things you care about, we have it pretty much. Oh, Mark, you're frozen for a second there. I'm not sure if you're still up or not. Yeah, so you're back.
Sorry about that, folks. Wouldn't you know it? See, internet is not reliable.
Absolutely. That's the problem.
As if to prove the point, I did it on purpose. So I also wanted to mention the C API support, right? So we go beyond mobile devices, and the C API allows you to embed data processing apps running on any custom embedded device. Think like agriculture drones or robot vacuums or surgical instruments, all real customer use cases.
Yeah, Raspberry Pi, all those kind of things you're normally looking up for an IoT, we've got that supported.
Totally. So get the app source code. And then if you go out and get your free trial of Capella, you can see that entire Couchbase mobile stack in action. This is where you set up app services and connect your simple sync demo to the endpoint for cloud to edge data sync. You can show exactly what we just showed within about probably less than 10 minutes. I'd say in 7 tops.
I've written a Couchbase.
So it only takes a few minutes.
Yeah, I've written a Couchbase app like application like literally 5 minutes before. I mean, just to do a simple, hey, go get the database, go get query, and get up and running. It's actually pretty fast. If you're a mobile developer out there, go look at 2 features. My 2 favorite features, if you're going to go look at it, is Live Query and Delta. And they were the 2 things when I saw Couchbase Mobile the first time, they changed my life. I was just like, this is crazy to see this technology and worked. And I mean, when you start using it and you just realize how easy it is, you just forget how bad things used to be. It's kind of addictive a little bit in the sense that you don't have all that tech that you used to have, and you focus on more features then, which is super awesome.
Nice. So listen, folks, we're right at the top of the hour, but let's see if there is a Q&A. Let's see if we can get through a few of them, and any that we don't, we'll entertain via email afterwards. Let's go through. I'm not seeing a whole lot. There is one person asking, device 1 is connected to the internet.
Yep.
Yes. Device 1 is connected to the internet going through app services. Device 2 is just on local network connected to device 1 and syncing via peer-to-peer. So assuming that's where the question was headed. Oh, there's a read more button here. Okay.
Yep.
Device 3 is only connected. Yes. Device was, if a change was made on device 1, the change will sync to device 3 once device 2 syncs from device 1. Yes.
That is correct.
Pushes Delta to the server. That is correct. You are 100% correct.
It's the same tech. So if you think about it, we don't care if it's another device or if we care if it's a app services. Sync is sync when it comes down to it. And that's the thing you have to wrap your mind around. The SDK just says it's another client out there that you're syncing to. So because of that, it doesn't really matter if it's a local device that's on peer-to-peer, is an app service, is another device out there. It just handles it, right? And then that's the beauty of the replication protocol that we have.
Exactly. I'm also checking the chat thread here to make sure some folks may have asked questions there.
There's another little bit more complicated one that we have here. So one of them was, how do you argument more complex backend logic? Is there a way to integrate existing backend logic while still using Couchbase Mobile? The answer is yes. So there's a couple different things you want to take a look at. So Couchbase obviously is a pretty complicated product. Inside of your data access and filtering script that you get, so inside of app services, there's a script that you can run, and that's custom JavaScript. You can put all kinds of complicated business logic in there. It's up to your heart's content. We also actually have a separate script that you can do for just importing documents. What should go to mobile? And this is where Mark was kind of alluding to, that a lot of times you don't want to send all the documents down to mobile, right? You may only want to send a subset to those. And you also can, at least in Couchbase 3.1, if you have scopes and collections, for example, you can just say, I only want this app endpoint to listen to these couple scopes and collections. You don't have to listen to everything on the server, right? You only have to listen to the things you actually care about. So there is ways that you could do that, where you can kind of add in your security, your data validation, the conflict resolution, all those kind of things. There are some custom JavaScript files and app services that you can modify that will give you the ability to do some of that logic on the server, right? And also, you can also do conflict resolution in the SDK on the mobile device also. So there's multiple ways you can handle this. But how stable is scope and collections this moment? I checked last year, and it was not in the development. Actually, so the real answer is scopes and collections have been developed for multiple years. I can know this. I have some inside baseball knowledge on that. We've been working on it for quite a while. It's very stable from that standpoint. Scope and collections was actually in preview in Couchbase Server 6.5. In mobile, they actually had most of the code for collections and scopes. I think at least the groundwork was done in 3.0. Well, 3.0, literally, technically speaking, the groundwork was laid for it. The 3.1 update was what actually enabled it, right? They had to change some back-end stuff to support this. And so that doesn't happen in one release. You take we're an agile team, right? We do things at Couchbase Agile. So we basically build ourselves up to actually get up to that point. So we made technology changes in 3.0 that allowed us then, when we got to 3.1, to make this big change happen and make it happen. But really, that's been going on for a while now. And the Fleece engine is super awesome. That's the back end that talks to the JSON serialization to Couchbase Lite. That's really where all the bread and butter is. It's super fast and very efficient. 3 is, are you guys supporting batching updates as well? You can if you want. You can. It's however you want to do those updates. So batch updates is in the SDK on mobile. So there is a per language, it's a little bit different, but like in Kotlin, for example, it's just a batch function you call, and you can have like 100 updates go. And it's really popular in IoT more than anything else. We have a ton of sensors going. You want to batch those up in maybe groups of 1,000 or 100 to 1,000, whatever that number is. You'll want to batch those updates up when you're doing multiple data calculations per second. You definitely want to batch that stuff up. That is supported in SDK and iOS, Kotlin, .NET, et cetera, et cetera. And then the last one, real mobile problem dealing with threads. How does Couchbase Mobile support threading? So this is a little bit different. So in Kotlin, we support coroutines and we support scope. So in Kotlin, for example, you'll say you have a scope, and one of the scopes is actually I/O. And what happens is when you set your scope to I/O, you're going to run in the background thread. So in Swift, you want to use the dispatcher, right? The dispatcher will get you it's called Grand Central. Obviously, in the new versions of Swift, there's something called async. Both of those are going to give you the ability to run off the main thread onto a background thread. You can talk to the database that way. Bring your data up. You usually want to encapsulate it in something like a view model. Depending on how you're going to do your strategy of that, it doesn't really matter. But really, remember that we're disk I/O. We're no longer network latency. We're more about talking to that disk that's on the local device. It handles doing the syncing between the server and stuff, and it's done efficiently. We don't use REST APIs to sync the data. We'll just put it that way. We use WebSockets, and a much better piece of technology to do that. But absolutely, you can get off the main thread without problems. I do it all the time. In .NET, I use async await, or you can also use tasks to actually get off the main thread if you want to. It's really up to you to decide. But in Kotlin, I think the coolest way is with coroutines. And then obviously in Swift, depending on what version you're using, you can use async or you can use dispatchers. Sorry for talking fast. Just trying to get through it while we have time.
Please, yeah, no, that's absolutely. I think we might have to wrap it up, but I do see some others. Is there one more that you think you can address pretty quickly before we wrap up, and we'll do the rest?
Let me see here. Is there any chance of having an actual React Native SDK support without creating our native bridge by ourselves? There is a sample out there how to do it, but I know it has been updated a little bit while. I don't have anything official I can talk about there. I know it's something that we've been talking about, but unfortunately, I don't have anything official I can say today. And that's something that's definitely known. So Flutter is supported by the community, and we may be looking at in the future, maybe possibly even doing a community thing like we do with Flutter. But I don't have anything official I can announce on that today. So sorry about that. For right now, there is a code example out there. You would do bindings based on that, and that's how you'd get support for it. So we do have some code examples of how to do that, but really it's up to you to kind of maintenance those bindings yourself.
All right.
Yeah.
So I guess with that, we'll go ahead and wrap it up. Aaron, thanks so much. And over to Suzanne for any closing comments.
No closing comments, just another reminder to check out track 2. We'll have those demos that goes further into the code of how those syncs were built. So you'll definitely want to check that out. And other than that, thanks so much, Aaron, for joining us. It was wonderful to have you. And hopefully we'll see you all again very soon. Take care.
Absolutely. Thank you.
Thanks, everybody. Thank you, Aaron.